Hello, and welcome back to my Java tutorial series to teach you how to program a physics simulator. A lot of results from the last episode. I'll just run that real quick, because we all love seeing successful programming. At the beginning of every episode, we made it a couple episodes ago, so you can add your own forces and such. And, adjust where they are, but as you can see, that's blue. What's up with that? Didn't we set the color to black? But if we actually happen to send something else out, and we set it to something similar, you realize the blue is the resultant vector. If we actually set this to 75, this will be exactly straight, and it should equal 75 times the square root of 2, if I'm correct about my trigonometry. But obviously, we don't know. So this episode, we're going to solve that problem. And what we're going to start with is we're going to make a new class. Now this class is going to be called NetPanel. And by net, I mean net force, net vector, not net acceleration, that's something else. But yeah, it's going to contain all the information about our net force. As always, shut up. This is going to extend JPanel, and of course we need to import JPanel from our good old friend javax.swing. So right here we're just going to do, since it extends JPanel, a private static final long serial version UID equals 1. Stupid stuff like that. I know, right? Now we're going to do a public static JLabels. We all love JLabels. I hope. This is going to be the force label, and then the vector label. And then we can go into our constructor, which, this class is very simple. All it's going to be doing is displaying some things. All we have to do is organize swing. We call super, just because. I don't even know if there's a reason. I guess it's common courtesy. I mean, panel always wants to hear from its children, because, it's a very sensitive parent. New box layout. On another note, I'm sure we're all familiar with box layout by now. I hope. Now, we won't be able to edit anything since the net force, so we don't have to deal with buttons or anything. We're just going to do force label equals new J label net force equals plus, well, you guessed it, we're going to turn it into a float. If you haven't guessed it yet, we're going to be referencing renderer.netForce. But we're going to turn it into a float because doubles are a lot bigger than floats. They're I think it's binary, so you can't say it's twice as big because it's twice as many bits. It's probably like at the very least 4 times. It's several orders of magnitude larger than a float is what I need to say. So if you turn it into a decimal, it's going to have like a crap ton of decimal points, which will probably flood over and turn into something ugly on the confined space that this panel is going to take up. So we turn it into a float so it has a limited amount of precision and won't take up a gratuitous amount of space. Okay, so the vector label will be a new J label. We're going to say net vector equals plus, again, converting to a float, renderer.netVector plus, I think we need to go back to force list. Nope, we need to go back to force panel and steal this degree symbol. And of course, if we save it, we should get that obnoxious error. And we didn't. Okay, already saved as the correct format. Then all we need to do is, just add force label, add vector label, set our border, so it's always fancy, especially one of my favorite is, create a titled border. We're just gonna say net force in caps, because that's how the gentlemen do it. Now we're just gonna set the bounds. We want it to be in the lower right, but not absolute lower right. Let's try 300, 500, 250, and 60. Yeah, those seems like perfectly logical amount of numbers. Now, how we're going to do this is a couple things. First, we're going to go into render. This runs every tick, obviously. So what we're going to do down here, actually, let's do it up here, because let's switch it up. We're going to do, we're going to do net panel dot force label dot set text, so it updates every, I mean, we don't need to update it this often, but it's simpler that way. We're just going to go back here, and we're going to grab this. And we're going to do the exact same thing for the vector label. Let's see, then we need all this. Okay, so now we have that. Sets at every tick. I don't think we really need to do anything else with renderer for like ever. So, you know, say goodbye to renderer for now. Done us a lot of good work. Well, it still will, but you know, we don't have to look at it anymore. And net panel, surprisingly, that's done. But main, what I want you to add is do, let's see, do I want to change this? I mean, not sure. Sure, why not? Public, static, net panel, net panel. I don't know. Should I have it like that, or... Should I have, like, just add a new net panel? Or should I have no idea. Probably I don't need to do this. Let's just say screen panel. We're going to add it to the screen panel because we're cool like that. But no, we don't want action. What am I doing? We want to add a new net panel. That would probably be good. Now, the other thing we need to do is force list on value changed. I'm going to do if. We're also going to do an else, since we're going to also fill that in soon this episode. And then also we're going to do main, not math, what am I doing? Math.screenPanel.add new net panel. Okay, so now let's open this up. Okay, you can see our net force. Now, if we add an applied 1 and give it a vector of 50, our net force is now 50 at the direction 0. Now we'll do, set that to 45, and now you can see it's 45. Now we're going to add applied force 2. It's also going to have a force of 50, and right now that's our resultant vector. We can see it's exactly between them, because between 45 and 0 it's 22.5 degrees, so that's exactly right. And then that's using the Pythagorean theorem exactly to find it. So now we're going to actually set this to negative 45 degrees, which now it's at 0 degrees, and it's a bit shorter. If you use your calculator, that should actually be 50 multiplied by the square root of 2. But hey, just fun fact, you know. So now that should work absolutely perfectly the way we want it. But now we want to change one thing. So now we actually have to go back to force list again. Oh wait, no, we have to go back to force. And what were we going to do? We're going to change this to free body, since this is a free body diagram. And we're going to add a new class. What do you know? And this is going to be called the body panel, because everyone loves bodies. You probably don't understand that. Either way, now we're going to import java.ot. All we need is event, because this one does have a button, but all we need is an event. Import javax.swing, yeah. Body panel, of course. What else is it going to do besides extends jpanel? Why did I put a semicolon there? Gosh, everything's getting into my head, man. Like final long serial version UID equals 1. Yay. Now we're going to have a couple things. We're going to have a private float. The mass of the object will equal 10 by default, which will be 10 kilograms. And then acceleration will equal 0, since at the beginning the net force will be 0. Okay, then some private J labels of a mass label and an Excel label, not Excel like Microsoft, but Excel like acceleration. Body panel, again, will be kind to our parents and send a super call to them. Then we're going to set our layout. Can you guess what layout it's going to be? Can you guess? Oh, look. Box layout. Now, before, I never really used any layouts. I always use absolute layouts. But, you know, box layout is pretty cool. It's definitely my favorite so far, because in order to make almost any very nice layout you want, all you have to do is a lot of panels, all of them with box layouts, just different orientations. At the beginning, we're going to do this acceleration equals the float. We convert it to float since acceleration is a float. Renderer dot net force divided by this dot mass. Since force equals mass times acceleration, that means acceleration equals force divided by mass. Okay. What am I doing? Oh, my keyboard. Oh, my... Stop. Just stop. Thank you. Sorry about that. My keyboard. Fucking keyboard. We'll get back to what we were doing. Equals new J label, capital L. Is that a capital? Yeah, it's capital L. Mass equals mass plus kilograms, because in force equals mass times acceleration, mass, not weight is something completely different. I mean, if you didn't know that, but it is in all seriousness. But mass is, yeah, it's always in kilograms. Weight, on the other hand, is always in newtons. If you don't know your physics, I hope you research it. Not many things are, you know, more funner even than physics. And acceleration is going to be in meters per second, because that's acceleration, obviously. Okay, also we want to do to make things easier, implements Actionlistener, and I'll just lay that out. Public void action performed action event, which to my knowledge extends event, but you know, events are a bit more primitive. So J button, mass button equals new J button, except this time we're actually going to make it say something. We're going to make it say edit. What do you know? So that'll be edit, and then we'll do mass button, just for common courtesy. We don't even need it. We can do set action command, and it's just going to be mass. Yeah, we don't need that. We don't need that at all. Again, just common courtesy. Add action listener this, since this is the action listener. Now we just need a J panel. Well, we need two actually. J panel equals new J panel with a semicolon to end the line. Then we need to set the layout. Should we try a new... No, we're not going to try a new layout, because box layout is pretty awesome. Just, you know, mass panel, then box layout dot. This time it's going to go along the edges. Well, it's going to go left to right. Mass panel dot add mass label mass panel dot add box dot create horizontal glue, which again will make as much space in between this and the next component as possible, and then we're gonna add mass button. because that's how we roll, bro. Continuing. Now I need a new JPan. Oh, I almost forgot the most important thing. It's not the most important thing. We're going to be setting the border. We're going to go into our newly fabricated border factory. We're going to create a raised bevel border. Those are so pretty. Excel panel equals new JPanel. My spelling. Do I even know what I'm doing? No. I know what I'm doing. If I didn't know what I was doing, I wouldn't be making a YouTube series about it. Now, would I? Now we're just going to set the layout. Oh, no, we have to do the new. Excel panel. Is it box layout? I don't even think we need a layout here. We're not going to be having that much. Box layout.x-axis. Yeah, and then we'll do Excel panel dot add our Excel label, so you can see the acceleration. Excel panel dot add box dot create horizontal glue. We're not going to add a component after this. We just want the label to be as far from the right side of this component as possible. So the last thing we're going to do with this thing is going to set the border, and it's going to be our nice and pretty raised bevel border. Now all we have to do is add mask panel, add Excel panel, set border. Again, we go into our border factory, dot create titled border. We'll just call this one free body. And last thing we're going to do, set bounds, the exact same as our, our force panel, which is 50, 300, 100. 100 seems a bit gratuitous. We'll see how it looks. But before we see how it looks, we're going to go into our action perform section and tell it what to do. Which is easy. We've done this all before. We're going to do float old mass equals this dot mass, and to prevent some mistakes, the original value of new mass would be old mass. It's also going to help us avoid redundancy. Now here we're putting it in try because we're going to be opening another J option pane. We're going to say new. Actually, just so we can make this easier, where is it? There we go. Okay. There we go. A lot easier. Except it's not new force, it's new... What the hell just happened there? New mass. We're going to parse this float. Enter the body's new mass. You're editing the body. If I can spell it right, you're editing the body, that is. Old mass. To string. Gonna parse that. Of course, you always gotta parse it. Then we're gonna just put the brunt of our things in here. We'll return if those are equals, because that means, it didn't really do anything. We don't care about it. We're gonna do this dot mass equals new mass. This dot acceleration equals exactly what we did in the constructor of this method, which is renderer.netForce divided by this dot mass. Then what to do, we're just going to set some labels, which I think we can go back to force list and find no, we can go back to, what do you know, our old friend, old and renderer. Wait, why am I? No. Wait, no, that's not what we're doing at all. What the... my apologies. Let's see. Mass label dot set text. This. So we can update everything. Then we'll do Excel label dot set text. Let's see. Now, that should be all we want to do. Now, of course, we'll catch our number format exception. We'll put our thing in there. We'll catch our null pointer exception, which we obviously don't care anything about. And then we'll do our finally bracket, which we can definitely find the finally stuff in force list. Wait, no, it's force panel. I'm always getting those two confused. My apologies. Now if we go back to body panel, we go up to here, and we get rid of that extra thing I accidentally copied. Input was invalid number. Of course it was. How could you? Then we'll just add these so the whole thing refreshes. Now, hopefully this... Oh, wait, no, we have to actually add it now. Silly me. Let's see, does this have any static things on it? Nope. Well, nothing important. So that means we can just do... screen panel dot add new body panel. Then if we go to force list, yep, it's this one this time. Now here's where we do the else. Main.screenPanel.add new body panel. Okay, here we go, guys. Oh, this is maybe not a finished product. I'll probably release it as is. But it's not a different project. I mean, come on. We're only at version 0.0.1. Of course there has to be more to come. Eventually. So we're going to apply force 1. Let's see. This sphere, this circle, is obviously a car. And it's driving forward with... at 70, with 100 newtons of force. It's how much this engine is pulling out. Now, if this car actually weighed 10 kilograms, it would be accelerating at 10 meters per second. Let's say it was more me. I weigh approximately 75 kilograms. If I was running forward, if I was riding my bike, which is a lot more, if I added the weight of my bike, wait, why didn't it save that? Okay, we need to fix something. So what we're going to do with body panel, we're actually going to make something else. We're going to do public static body panel, body panel. What we're going to do, we're going to reorganize this. Actually, no, we're not going to reorganize this at all. We're going to cut this, put body panel, and we're just going to say body panel equals new body panel. And when we go to force list, when we actually switch selections, it's not going to add a new body panel, but it's going to add main.body panel. Wait. Did I put that in main? Main.body panel. Sorry. I did not see that. So now it should work again. So if I go up here, and as soon as it starts to pop up, me and my bike together, we weigh about 100 kilograms. Now let's say I'm riding my bike forward, whatever. Okay, it's still 100 kilograms. We're good. So let's see if I was riding a force with, let me think. Normally I'd be riding about 15 miles per hour at an average speed. I don't know what that is in meters per second. Velocity doesn't even matter. What am I kidding? Okay, 100 newtons. Right now I'm accelerating at, wow, something's wrong. Obviously I'm accelerating faster than 0 if my force is that much. Actually, mass. Net force is 100 newtons. My mass is, so if I was accelerating at that much, it would be, I should be accelerating at 1. Let me try to increase this. It's not even working. Okay, maybe I'm doing something wrong where it's setting the acceleration. Acceleration equals 0. Okay, now I know. When you update your force panel, what we want to happen is that when this happens, renderer maybe, yeah, we might want to put that in the render. No, we don't want to put that in the renderer, do we? Okay, do we want to put it in force panel or body? Well, we can't put it in body panel. So basically, what's happening is that the acceleration isn't updating for whatever reason. Where do I have it setting acceleration? In force panel, when you're done editing something, it should resort to that. So I think we're just going to put it in here. So we're going to go the body panel equals the same every time. But the problem is when you edit the mass, it changes the acceleration. But I don't think it changes it under any other circumstances. So we're just going to run it here. Actually, that doesn't work. Oh, what's wrong this time? Well, I know exactly what's wrong. The problem is we want to figure out how to fix it. That is where the true fun begins. So an easy way to do that would you make this public. No, that would not be the easy way to do this. I'm mistaken. The easy way would be to make this public. Would it? Yes, it would. So that means now we want to do exactly this. Now if we go to force panel, oh wait, we already have this here. So do main dot body panel. Where the hell is body panel? Main dot body panel. I don't know why I can never see that. Main, okay. Crap. Do I really have to change that? Or should I just do a get mass, get force? We'll do a get mass, get force, yeah. Seems sensible. So, public float get mass, return this dot mass. Public float get acceleration. I don't know why you would ever need to get acceleration. Return this, but in common courtesy. That's it. When you do get set, you normally do it for a lot of things. So we can just do this dot get mass. So that's not really working. We need to, what do we need to do? Yeah, I think we need to put this in render. No, because what it's doing, it destroys those when it removes it. So that would give us a null pointer exception. What we want to do is that when we... I'm sorry, this episode is probably getting kind of long, but hey. Is it not worth it? Is it? Can expand this, and we're going to do main dot body panel dot update. No, we don't want the generic update. We want to do modify. That's a great name. Main.body panel modify. Now we get to add our own method, which will be public void modify. Doesn't make that much sense, to be fair. Okay, let's try it now. So it modifies every time you switch. So I'm going to do 100 for the total apparatus. Applied force 1 will give us a speed of about 100 newtons. Now, as you see, my acceleration is 1 meter per second squared, which isn't bad at all. So now let's say we just happen to have the force of friction. Now, if we had the force of friction, it would be going in the opposite direction of where we were going. So it would be at 180, and let's say I had a force of 25. Now, our net force is now 75. And my acceleration as a bike would be a lot less. Now, it doesn't matter, but there also happens to be the force of gravity. Now, that's going straight down, and that's going straight down, so it would be going at 270, or negative 90, and that force would be exactly equal to my mass, which would be 100. This might work. 100 times 9.81. Okay, it was an invalid number. I'm going to try that one more time. Maybe if I put it in parentheses. I'm trying. 9.81. Ah, crap. Wait, this is simple math. 98.1 newtons. Or is it 900? 9.1. Okay, it'd be 901 newtons. Holy crap. You can understand why it's discrepancy, but the point is, since I'm also on ground, there'd be a normal force, which would actually be at 90 degrees, and it'd be exactly the same. It'd be 981. So while these are going up and down, crazy things, which is one of the reasons why next episode, we're going to be adding another panel for you to adjust the scale, and if we have enough time. Unlike this episode was a bit long, I apologize for that. We'll add like a little panel up here where you can adjust the scale. So if your forces are in extremely large magnitudes, you can move the scale and everything can scale up or scale down depending. The free body will stay the same size though, just for convenience. But you can see our program works. Let's say something was crazy and friction was not going parallel to our slope. Quite the contrary, it was going 130. Now I'm flying. Me as a bike, I'm flying. So yes, there you go. This has been a wonderful physics simulator. Next episode, as I said, we'll be focusing on some more things, but this episode, again, I must repeat, I am sorry for its length, but I hope you enjoyed this episode. We covered our two targets today, and I will see you next time. And as always, good programming to you.